So we've been talking about equations for a while, but how can we write a math sentence where something is not necessarily equal to it? I guess that would be an inequation. Well, we got a few of them. There's the greater than, less than, greater than or equal to, less than or equal to, and more infrequently used is just the strict not equal to. But we're not really, there's really nothing to do with that, but you might see it sometimes, and that's just what that means. They inhabit the same spot in a math sentence as equalities, but it tells a different story. Instead of the variable or the expression equaling one distinct value, these tell us that there's a whole range of values. You've probably seen these alligator mouths before, but just so you can see, rude. So like 5 is greater than 3. 0 is less than 2. -1 is greater than or equal to -7. 4 is less than or equal to 4. You know, it can be everything that is greater than 4 or equal to 4. That's what that little line on the bottom means. So we can graph the range of values for these things if they have variables to them. So we say like x is greater than or equal to 3. Maybe I'll even use different colors. That sounds fun. Y is less than or equal to -1. Z is greater than or equal to... Was I saying or equal to for these? No, these are just stricts. You can't say like 1 is greater than 1. You cannot say that. Because 1 is not greater than itself. Oh, ran out of letters. W is less than or equal to 5. And I'll make this 4 a negative. Okay, so we go to the number line. We find 3. Oh, look, there it is. It really doesn't matter where your reference spot is. You probably learn it as, like, the middle point is 0, but, like... Yeah, okay. You know what? I'm going to retroactively make this red, because I feel like it's being left out. So you find 3, and then you kind of mark... If you're doing, like, black and white, paper and pencil and whatnot, you, like, really got to bolt it in, just to really make sure that we're hitting everything that's greater than 3. But what about 3 itself? Well, 3 is not in the solution set of this. The solution set for anything is just the answers that it can have. Technically, the solution sets for any of those equations were just one value, but for an inequality, we can say, like, the solution set is everything that's greater than 3. But not 3 itself, not for these ones. What we do to signify that we're making sure that 3 is not in the solution set, because normally what we do is, for a point, we fill in a circle, fill in a dot. But 3 needs to be disregarded, so we actually do kind of an open dot. I know it's kind of hard to see because my boldness is too much for this, but you kind of do an open circle. That means that tells us that everything up to 3, like 3.000, infinitely many zeros, 1, that doesn't really, it kind of does, infinitesimally close to 3, but not y is less than -1. So let's find -1. Let's start with the open circle now that we know what to do. So we do the open circle, then from that we can kind of go like this. There, that's better. Now for the inequality, these two guys, where it's or equal to, it's getting a little aggressive there. Need room for the dubs still. So it's z, or for the non-Americans, z is greater than or equal to -4. There we do put in the full point, the full circle, filled in, just like if it was just the 1 point. So we do the point, it's a filled in circle, so we know that it's part of the solution set, and then we go greater than. Yeah, so if you're ever confused on which way to go, you just kind of like put in a random number, like 0. Is 0 greater than or equal to -4? Yes. This is what's called a test point, and they'll really come in handy when we start doing systems of inequalities. Negative numbers and alligator mouths can be confusing. 0 is a great test number. 0 is part of the solution set, so that means everything that is this way on the number line. There's 5, and then less than or equal to 5. Cool.